For millions of years, Earth has been our sanctuary, a fragile blue world adrift in a sea of darkness. From its mountains to its oceans, it has sheltered every generation of humanity. Yet, for the first time in history, the idea that Earth might not be our only home is no longer a dream. It is a plan, a mission, a race against time. Something has shifted in the human story. Scientists from NASA, ESA, and private ventures like SpaceX are preparing for what could become the most transformative chapter in human civilization, the beginning of life beyond our planet. The Moon, Mars, and even distant asteroids are no longer unreachable mysteries. They are targets, mapped, studied, and prepared for settlement. Humanity stands on the edge of becoming a multiplanetary species. But why now? Why are governments, corporations, and visionaries investing billions in leaving the world that gave us life? Some argue it's a necessity. The Earth is warming, our population is climbing, and resources are shrinking. Others see it as destiny, an inevitable step in the evolution of a species that has always looked upward, wondering what lies beyond. History shows that every great leap began with a single moment of courage. In 1957, the Soviet Union launched Sputnik 1, a silver sphere that marked the dawn of the space age. 12 years later, Neil Armstrong took a single step on the moon and whispered a line that still echoes across generations. But after Apollo 17 returned home in 1972, silence fell. For decades, humanity stayed grounded, watching the stars but never reaching out again. Until now, recent discoveries have reignited our ambition. Water ice found on the lunar poles, signs of ancient rivers on Mars, and new propulsion technologies have given scientists reason to believe that permanent human colonies beyond Earth are not centuries away, but decades. The dream of lunar villages, Martian cities, and orbital stations is no longer science fiction. It is under construction. Yet, the road to the stars is paved with peril. To survive beyond our planet means confronting deadly radiation, bone-crushing isolation, and worlds where a single error can mean extinction. It is not just about rockets or science. It is about redefining what it means to be human. In this story, we will travel through time and imagination, from the first satellites to the coming industrial revolution in space. We will see how the race for survival has become a race for expansion, and how the universe itself may soon become our new frontier. Because one question now defines our age. Are we ready to leave Earth? And if we do, what kind of humanity will we become among the stars? Every great journey begins with a signal, a faint whisper in the static of human history. For the space age, that signal came from a small metal sphere launched into orbit on October 4, 1957. Its name was Sputnik 1, and its message was simple. Humanity had broken free from Earth's gravity. The world watched in awe and fear as the beeping pulse of Sputnik echoed across radio receivers. It was more than just a Soviet triumph. It was proof that humankind could reach beyond the cradle. 4 years later, in 1961, Yuri Gagarin became the first human to see Earth as a whole, a glowing orb suspended in darkness. "I see the Earth. It is so beautiful," he reported, his voice calm but filled with wonder. With that sentence, humanity's relationship with the cosmos changed forever. By the end of that decade, rockets had grown larger, faster, and far more ambitious. On July 20, 1969, as Neil Armstrong stepped onto the dusty surface of the moon, the impossible became real. The lunar soil carried the imprint of human feet, the first mark of our species beyond its birthplace. Millions watched the broadcast, their eyes wide with disbelief. In that moment, it seemed inevitable that the moon would become humanity's second home. But it didn't happen. After the final Apollo mission in 1972, space exploration slowed to a cautious crawl. The excitement of discovery gave way to political hesitation and economic reality. The moon faded from priority lists, and Mars became a distant dream postponed by decades. Still, not all progress stopped. A new era began, one that would move from fleeting visits to lasting presence. In 1971, the Soviet Union launched Salyut 1, the world's first space station. For the first time, humans could live and work in orbit for days, then weeks, then months. The United States followed with Skylab, and later, international cooperation would give birth to Mir, a modular station that stayed aloft for 15 years. These early habitats were fragile and small, but they proved something monumental. Humanity could survive in space. Then came the International Space Station. Built piece by piece from 1998 onward, it became a living laboratory orbiting just 400 kilometers above Earth. Over 2 decades, astronauts from 17 nations have called it home. They have grown plants, repaired satellites, and tested the limits of the human body in zero gravity. The ISS, with its vast solar wings and delicate balance of technology, became a symbol of unity, proof that cooperation could thrive even in the vacuum of space. And yet, beneath this peaceful collaboration, another race was forming, a quieter, more determined one. Private companies began to look upward, seeing not just exploration, but opportunity. SpaceX, Blue Origin, and other emerging players promised a new model: reusable rockets, cheaper launches, and the eventual colonization of other worlds. What once required the power of nations could now be achieved by innovation and risk. The rediscovery of water on the moon's surface reignited everything. Scientists confirmed vast reserves of ice trapped within its poles, not just frozen rock, but potential oxygen, fuel, and life support for future bases. Suddenly, the moon was no longer a barren relic of the past. It was a gateway, a place to test life support systems, construct habitats, and prepare for the next leap Mars. For centuries, the red planet had haunted human imagination. From ancient myths to telescopic sketches, Mars represented both mystery and hope. Now, for the first time, the dream had a deadline. NASA's Journey to Mars initiative, the European Space Agency's Moon Village, and the ambitions of private companies all pointed to one vision: permanent human presence beyond Earth. The first steps have already been taken: robotic rovers exploring Martian plains, satellites mapping lunar craters, engineers simulating Martian soil in labs on Earth. What was once science fiction has become a blueprint for the future. But even as humanity reaches for the stars, one question lingers: are we building new worlds for exploration, or new shelters for survival? Climate change, resource depletion, and the threat of extinction cast long shadows over our ambitions. Perhaps we are not expanding out of curiosity, but necessity. Perhaps space is not a frontier of dreams, but of survival. Still, every great leap begins with uncertainty. The same pulse that once echoed from Sputnik 1 now beats through the heart of a new generation. One that looks skyward, not just with wonder, but with intent. The first steps toward the stars have already begun, and this time, there may be no turning back. The story of space exploration began as a contest of power, a silent duel between nations striving for prestige. The Cold War had transformed the night sky into a battleground of science, politics, and ideology. Yet what began as rivalry would soon evolve into collaboration, and then into something entirely new: a global effort driven not by governments alone, but by visionaries who believed that humanity's destiny lies beyond Earth. In the 1960s, the United States and the Soviet Union stood as opposing giants. Their rockets were not only vehicles of discovery but symbols of dominance. When the Soviet Union launched Sputnik 1 and later sent Yuri Gagarin into orbit, the world witnessed the power of human ingenuity, but the U.S. saw a challenge. President John F. Kennedy's bold declaration in 1961, "We choose to go to the moon," ignited an unprecedented surge of technological and human effort. 8 years later, America's flag stood on lunar soil. The space race had found its victor. But once the contest ended, so did the momentum. Without the urgency of rivalry, funding dwindled and ambitions faded. Space exploration became the realm of scientists and engineers rather than heroes and poets. The golden age of space seemed over, until a new wave of thinkers arrived, people who were not generals or politicians, but entrepreneurs. By the dawn of the 21st century, a quiet revolution began. Private companies, once confined to supplying parts for government rockets, started building their own. SpaceX, founded by Elon Musk in 2002, promised to break the cost barrier that had long chained human exploration. Instead of disposable rockets, Musk proposed reusability, a concept dismissed by many as impossible. But with each successful landing of a Falcon 9 booster, the idea of affordable access to space became reality. Blue Origin, led by Amazon founder Jeff Bezos, followed with its own vision, a long-term dream of millions of people living and working in space. We need to move heavy industry off Earth, Bezos argued, so that our planet can remain a garden. His company's motto, Gradatim Ferociter, step by step, ferociously, captured a patient determination that contrasted sharply with the frantic pace of the 1960s. These visionaries were not racing each other the way nations once did. They were racing the limits of possibility. The goal was no longer just to plant flags, but to plant roots. Their ambitions reached beyond exploration, to colonization, sustainability, and even commerce. Meanwhile, traditional space agencies evolved as well. NASA, ESA, JAXA, and Roscosmos began shifting from being the sole actors in space to becoming partners and coordinators. NASA's Artemis program, for instance, aims to return humans to the moon and build a sustainable base by the 2030s. But unlike Apollo, this mission would not be a brief visit. It would be the foundation of a permanent presence, the next step toward Mars. ESA's Moon Village initiative envisions a multinational settlement on the lunar surface, a combination of scientific outpost, research hub, and industrial station. It's not a single base, but an open invitation for nations and private companies alike to collaborate. This new era of exploration is less about competition and more about coexistence, though the stakes are still immense. As technology advances, so do the possibilities. 3D printed lunar habitats, autonomous mining robots, and nuclear-powered spacecraft are no longer fantasy. Advances in AI and robotics allow machines to perform dangerous work before humans arrive, building the infrastructure needed for survival. Even asteroid mining, once a dream of science fiction writers, is now part of real-world investment portfolios. Companies like TransAstra and Deep Space Industries plan to extract metals, water, and propellant directly from near-Earth asteroids, resources that could fuel the next generation of missions deeper into the solar system. But as private industry rises, so do new ethical and political challenges. Who owns the moon? Who profits from Martian resources? International treaties written during the Cold War did not anticipate a future where corporations would rival nations in space. Questions about sovereignty, exploitation, and responsibility remain unresolved. Despite the uncertainty, momentum grows. Each successful launch, each discovery of lunar water or Martian ice, pushes humanity further toward the inevitable, permanent settlement beyond Earth. The second space race is no longer about nations competing for glory. It is about a species fighting for its future and learning how to coexist with its own ambition. From government laboratories to private launch pads, the torch has passed from the hands of statesmen to the minds of dreamers. They are building ships not for war or pride, but for continuity, the continuity of life, of knowledge, of human presence itself. And yet, behind all the dazzling technology and corporate optimism, one truth remains unshaken. Leaving Earth will not make us less human. It will test every part of what makes us human, our courage, our cooperation, and our will to endure. Because if we truly intend to become a species among the stars, the question is not just how we will get there, but who we will be when we arrive. Leaving Earth is difficult. Living beyond it is almost impossible. To build a permanent home among the stars means facing an environment that has never known life, where every breath, every drop of water, and every degree of temperature must be engineered. On Earth, we take our survival for granted. Gravity holds us steady, an atmosphere protects us, and the planet itself provides food and warmth. But in space, everything that sustains us must be created, maintained, and defended against forces that can kill within seconds. The moon, for instance, may be close enough to appear peaceful in the night sky, but its surface is one of the most hostile places imaginable. A lunar day lasts 14 Earth days, during which sunlight scorches the ground to more than 100 degrees Celsius. When darkness falls, temperatures plummet to below -180 degrees Celsius. There is no atmosphere to carry sound, no magnetic field to deflect cosmic radiation, and no oxygen to breathe. The soil itself, lunar regolith, is razor-sharp dust that can slice through spacesuits and clog delicate machinery. Building on such a world demands technology unlike anything ever used before. Engineers envision using 3D printers to shape habitats from the moon's own material, melting regolith into blocks that can be layered like bricks, sealing astronauts beneath domes of fused dust. These structures could shield against radiation, micrometeorites, and the brutal extremes of temperature. Other designs propose settling inside ancient lava tubes, vast underground tunnels carved by volcanic activity billions of years ago, where colonists could live safely beneath the surface, protected from solar storms. But even with shelter, the question of life support looms. A colony needs air, water, and food, elements that do not exist naturally on the moon. Scientists plan to extract oxygen from lunar soil, which contains metal oxides, and generate water from ice hidden in the polar shadows. Greenhouses, illuminated by artificial light, could grow plants that recycle carbon dioxide and supply both oxygen and nutrition. In time, the colony would become a closed ecosystem, a miniature Earth in a sea of darkness. Mars presents even greater challenges. Its surface gravity is only about a third of Earth's, and its atmosphere, thin, toxic, and composed mostly of carbon dioxide, offers little protection from radiation or cold. Temperatures average around -60 degrees Celsius, and dust storms can engulf the entire planet for months. Yet Mars offers something the moon does not: the promise of permanence. It has weather, seasons, and evidence of once-flowing water. Beneath its surface, scientists believe vast reserves of frozen ice remain, perhaps enough to sustain a settlement for centuries. To reach Mars, however, is a monumental feat. The journey takes 6 to 9 months each way, during which astronauts would be exposed to zero gravity and lethal cosmic rays. Muscles waste away, bones lose density, and radiation damages DNA. Every extra day in deep space increases the risk of cancer and cardiovascular failure. Shielding a spacecraft from such dangers requires either heavy materials, which increase launch costs, or innovative designs, such as water-lined walls or magnetic fields to deflect radiation. And then there is the psychological toll. Long isolation, confinement, and the endless silence of space can erode the human mind. On Earth, astronauts aboard the International Space Station already face these issues after just months in orbit. Imagine years spent millions of kilometers away, with a communication delay of up to 20 minutes between Earth and Mars. In such conditions, even a simple conversation becomes a test of patience, and loneliness becomes a constant companion. Yet humanity's answer to these problems is not retreat, it is adaptation. Scientists are experimenting with artificial gravity, using rotating habitats to mimic the pull of Earth. Engineers are designing advanced life support systems that recycle every molecule of air and water. Psychologists are studying group dynamics and stress resistance to prepare future crews for the mental demands of isolation. The solutions may be complex, but each one brings us closer to the moment when home will no longer mean one planet. Beyond the technical hurdles lies another question: energy. To survive on the Moon or Mars, colonies will need continuous power. Solar energy seems ideal, but it is unreliable during long nights or dust storms. Nuclear fission offers a stable alternative, capable of running for decades without sunlight, but it raises concerns about safety and cost. Future outposts might rely on a combination of both: solar farms for daylight and compact reactors for darkness. Energy will be the heartbeat of any off-world civilization. Still, even if all these challenges are overcome, the greatest obstacle might be philosophical. Humanity has never lived without Earth's embrace. To build a home beyond it means redefining what it means to belong. How will future generations born on the Moon or Mars see themselves? As Earthlings, Martians, or something entirely new? Will they look back at our planet with nostalgia or indifference? These are questions that no machine can answer, and yet they may determine whether our expansion into space becomes a triumph or a tragedy. We are learning to build homes in the void, fragile bubbles of life suspended in deathless silence. It is a task both terrifying and magnificent. And as the first foundations are laid, humanity takes another irreversible step toward a future where home is not a place, but a network of worlds. For all its familiarity, the Moon remains an alien world. It rises over Earth every night, bright and unchanging, yet it has never stopped calling to us, a silent witness to our entire history. For generations, it was a symbol of wonder and mystery, a place of myth and poetry. But now, for the first time, it has become something else, a destination. Humanity's first true step toward living beyond its birthplace. The Moon is only 384,000 kilometers away, close enough to reach in a matter of days, yet distant enough to demand the full measure of our technological genius. It is the natural stepping stone for deeper exploration, the ideal testing ground for survival in hostile worlds. And with the discovery of water ice near its poles, it has become not just reachable but inhabitable. The turning point came in 2009, when NASA's Alcross mission confirmed the presence of significant amounts of water in the lunar soil. For decades, scientists had assumed the Moon was bone dry. The revelation changed everything. Water is more than a resource. It is the foundation of life and the fuel of exploration. From it, we can extract oxygen to breathe and hydrogen to create rocket propellant. The Moon, once seen as barren, suddenly appeared full of potential. Today, the race to return is well underway. NASA's Artemis program aims to send astronauts back to the lunar surface by the mid-2030s, not just to visit, but to stay. This time, they will not plant a flag and leave footprints in the dust. They will build the first permanent base. The Lunar Gateway, an orbiting station serving as both laboratory and logistics hub, will circle above, linking Earth to the Moon like a celestial bridge. The goal is clear: establish a sustainable human presence that can support future missions to Mars and beyond. The European Space Agency has its own vision, the Moon Village, a collaborative international effort that invites nations, corporations, and private groups to contribute modules, technologies, and ideas. It's not a single city, but a network, a shared foundation for humanity's expansion beyond Earth. As ESA's former director Johann Dietrich Werner once said, "The Moon Village is not a project, it's an open concept. On the Moon, everything must be reinvented. Construction, power generation, communication, and even daily life operate under unfamiliar rules." Engineers propose several approaches to building lunar habitats. Some designs involve landing prefabricated modules, inflated structures shielded by layers of regolith for radiation protection. Others envision robotic 3D printers that use lunar dust to create walls and domes, melting minerals together using concentrated sunlight or microwaves. There are even proposals to settle within the Moon itself, inside vast lava tubes, hollow tunnels formed billions of years ago by ancient volcanic flows. These caverns, some large enough to fit entire city blocks, offer natural insulation against radiation and extreme temperatures. Hidden from the deadly solar winds, they may one day shelter the first lunar settlers, humanity's cave dwellers of a new age. But life on the Moon will demand more than shelter. Colonists must learn to produce food, recycle air, and store energy for the 2-week-long lunar night. Artificial ecosystems, greenhouses filled with plants and microorganisms, will form the beating heart of every base. Their role is not only practical but psychological, a reminder of Earth's living world amid endless gray. Power remains one of the greatest challenges. During the long lunar day, solar panels can generate abundant energy, but when darkness falls for 14 Earth days, another source is needed. Nuclear reactors, compact and self-sustaining, may provide continuous power, but their deployment raises concerns about safety and logistics. Some scientists propose a hybrid solution, a global network of solar stations spread across the poles, ensuring that at least one installation is always in sunlight. The choice of where to build is critical. The polar regions, especially near the Shackleton crater at the Moon's south pole, are favored for their near-constant sunlight and proximity to ice deposits. Constant light means stable solar energy, while frozen water nearby can sustain life and fuel production. In contrast, the equatorial regions offer access to rare materials such as helium-3, a potential fuel for future fusion reactors. Each location offers opportunity and risk, and the final decision may depend on the needs of international partnerships. Yet the Moon is not simply a resource or a laboratory. It is also a psychological threshold, the line between Earth and the infinite. For the astronauts who will live there, every glance at the distant blue sphere will carry the weight of home. Earth will appear in the sky, bright and silent, a reminder of both separation and belonging. In time, lunar bases will evolve from outposts into settlements. Small crews will give way to rotating teams and eventually to families. Children born under 1/6 of Earth's gravity may grow up seeing the Moon as their homeland, with Earth as the foreign world below. New cultures, traditions, and even languages could emerge, shaped by a life lived under eternal darkness and light. But before that day arrives, humanity must first overcome the Moon's silent hostility. Radiation, dust, isolation, and the ever-present risk of catastrophe will test every invention, every plan, and every person who dares to stay. And yet, as history has shown, the impossible is often where humanity finds its greatest triumphs. The Moon will not be humanity's final destination, only its beginning. It is the gateway to Mars, to the asteroid belt, and to the wider solar system beyond. Once we learn to survive there, the rest of the cosmos will no longer seem unreachable. We have gazed at the Moon for millennia. Soon, we may gaze from it, watching Earth rise above the horizon, a fragile reminder of where our journey began. For centuries, Mars has haunted our imagination, a red spark in the sky, a distant reflection of both mystery and hope. Ancient astronomers believed it was a wandering star touched by war and fire. Modern scientists see it as humanity's most likely second home. No other planet has captivated our curiosity so completely. And now, for the first time in history, we are on the verge of turning that fascination into reality. Unlike the Moon, Mars is a world in its own right, a planet with mountains, valleys, and polar caps of ice. Its day lasts just 24.6 hours, remarkably similar to Earth's, and its surface bears the scars of ancient rivers and seas. Once, long ago, it may have been warm and wet, a place where life could have taken root. Today, it is cold, silent, and barren, but not dead. Beneath its thin carbon dioxide atmosphere, there may still lie the ingredients for renewal. NASA's Journey to Mars program, along with international efforts led by ESA, JAXA, and private companies like SpaceX, represents the boldest human ambition ever conceived: to transform Mars from a distant dream into a second home. The plan is not simply to visit, but to stay, to establish a self-sustaining colony capable of supporting generations. The path to Mars begins with a journey unlike any before it. The average distance from Earth is about 225 million kilometers, and even at closest approach, it takes 6 to 9 months to arrive. This means any mission must endure extended isolation, with no quick rescue possible and a communication delay of up to 20 minutes each way. A human mission to Mars is therefore not merely a test of engineering, but of endurance, both physical and psychological. The first human footprints on the Martian surface will likely follow decades of robotic exploration. Rovers like Spirit, Opportunity, Curiosity, and Perseverance have already mapped the terrain, analyzed rocks, and discovered evidence of ancient riverbeds and organic molecules. Orbiters continue to survey the planet's surface, locating sites rich in ice and minerals that could one day sustain human life. Each discovery brings us closer to understanding how to survive there and what we might find. Yet even with all our technology, Mars remains an unforgiving place. The planet's gravity is only about 1/3 of Earth's, and its atmosphere is so thin that liquid water cannot exist on the surface without evaporating or freezing instantly. Temperatures swing from a mild 20 degrees Celsius in the sunlight to minus 100 degrees Celsius at night. The air itself is toxic, a suffocating mix of carbon dioxide and trace gases. Radiation, both from the sun and the cosmos, bombards the surface continuously. To endure such conditions, we will need habitats that are both durable and adaptive. Some designs propose underground colonies carved into Martian rock or buried beneath layers of soil for protection. Others imagine transparent domes made of glass and polymer, filtering sunlight for greenhouses that produce oxygen and food. SpaceX's vision of Starship includes transporting modular habitats, power systems, and supplies directly from Earth to Mars, where they could be assembled into the first settlement. Water, once thought scarce, may be the key to survival. Observations from orbiters have revealed vast reserves of frozen ice beneath the Martian poles and even near the equator. Melting that ice would provide water for drinking, oxygen through electrolysis, and hydrogen for fuel, enabling the creation of a closed-loop system that recycles resources with minimal waste. In time, such technology could allow colonies to grow independently from Earth, turning Mars into a self-sustaining world. The challenge of energy is equally critical. Solar power is viable, but sunlight on Mars is only about half as strong as on Earth and can vanish completely during months-long dust storms. For that reason, nuclear fission reactors are likely to serve as the backbone of early Martian energy systems, providing reliable power for life support, heating, and communication. Future colonies might even experiment with fusion reactors, or with harnessing energy from chemical reactions using Martian resources. The idea of terraforming, transforming Mars into a more Earth-like planet, has fascinated scientists and dreamers alike. Theoretically, releasing greenhouse gases could warm the atmosphere, melting ice and thickening the air to support liquid water. However, studies suggest Mars lacks enough carbon dioxide to make this feasible anytime soon. True terraforming remains a dream for future centuries. For now, survival depends on sealed habitats and human resilience. But there is more to colonizing Mars than engineering. There is philosophy. The Red Planet is a mirror held up to humanity, a place to confront our own limitations and desires. What drives us to cross the void? Is it survival or curiosity? Is it a need to escape our mistakes, or a chance to begin anew? Every rocket that leaves Earth carries not just machines, but the entire history of human ambition. There are those who argue that we should fix our home before seeking another, that building colonies on Mars while Earth faces climate crises and inequality is a contradiction, an escape for the privileged rather than a mission for all. Others see it differently, exploration as salvation. Technologies developed for Mars in recycling, renewable energy, and agriculture could transform life on Earth as well. The two worlds are not in competition. They are reflections of the same struggle to endure. The first human to stand on Mars will look up and see a pale blue dot glowing faintly in the sky, their birthplace, distant but visible. It will be both humbling and liberating. For the first time, we will see Earth not as the center of life, but as one of many possible homes. That moment will mark the beginning of something irreversible, the era of interplanetary humanity. Mars is not an escape from Earth's problems. It is an extension of our story. The Red Planet will test our courage, our creativity, and our capacity to adapt. It will force us to confront what kind of civilization we truly are, one that consumes its home, or one that learns to build new ones. And as we take that next great leap, one truth will echo across the cosmos. Wherever we go, we will carry Earth with us. In our technology, our culture, and our unending desire to explore. If space is the final frontier, it is also the ultimate adversary. For all its beauty, the universe is indifferent to life, a vast expanse of silence and death. Beyond Earth's protective atmosphere, every moment is a negotiation with danger. The human body, evolved for the comfort of one planet, begins to unravel the instant it leaves. To live in space is to live on borrowed time. Cosmic radiation, high-energy particles streaming from the sun and from distant supernovae, constantly bombards everything beyond Earth's magnetic shield. On the International Space Station, astronauts receive doses of radiation hundreds of times greater than on the surface. Prolonged exposure damages DNA, weakens the immune system, and increases the risk of cancer. On a months-long journey to Mars, that danger becomes existential. NASA studies suggest that without proper shielding, astronauts on a round-trip mission to Mars could absorb a lifetime's worth of radiation in a single voyage. To survive, spacecraft must become fortresses of safety, walls lined with water, hydrogen-rich materials, or even magnetic fields designed to deflect charged particles. Future colonies may use Martian soil itself, packed meters thick, as a natural barrier against cosmic rays. The solutions are costly, but the alternative is extinction. Radiation is only the beginning. The absence of gravity, something so fundamental that we barely notice it on Earth, is one of space's most insidious threats. In zero gravity, muscles waste away, bones lose calcium, and fluids drift toward the head, straining the eyes and brain. Astronauts aboard the ISS combat these effects with hours of exercise each day, but long-term missions will require more. Artificial gravity, achieved through rotation, could restore balance to the body, yet such systems remain experimental. Beyond the physical lies the psychological. Humans are social creatures, wired for sunlight, open skies, and the subtle rhythm of life. In space, all of that vanishes. Days blur together in endless cycles of mechanical noise and artificial light. Every sound, the hum of air filters, the click of instruments, becomes part of a relentless monotony. Isolation eats away at sanity. Even on the ISS, just 400 kilometers above Earth, astronauts have reported feelings of depression, anxiety, and detachment. On Mars, where communication with Earth suffers a 20-minute delay each way, the sense of isolation will be absolute. No real-time conversation, no instant reassurance. For future colonists, loneliness will not be a mood. It will be a constant companion. Psychologists studying analog missions, such as HICs in Hawaii or Concordia Station in Antarctica, are beginning to understand what long-term isolation does to the human mind. Conflicts arise over small details. Noise, privacy, hierarchy. Group cohesion becomes fragile. In such conditions, emotional stability is as critical as oxygen or water. The ideal crew for space may not be the strongest or smartest, but the most balanced, individuals capable of empathy, patience, and endurance in the face of endless confinement. Food and water, too, are battles of survival. Every gram launched from Earth costs thousands of dollars. Future colonies must grow their own sustenance. Hydroponic systems, algae bioreactors, and genetically engineered crops designed to thrive in reduced light and gravity. Closed-loop ecosystems, where waste is recycled into resources, are the only way to survive for years without resupply. The dream of independence begins not with rockets, but with soil, even if that soil must be created inside a metal dome. And yet, amidst all this danger, the most fragile element remains human trust. On a distant world, a single mistake can destroy everything. A faulty airlock, a contaminated water supply, an argument that turns into violence. Survival depends not only on technology, but on cooperation. Each person must trust that the others will do their duty, even when the Earth itself is just a fading in the sky. For all our training and preparation, space remains an arena of unpredictability. Solar flares can knock out communications. Micrometeorites can puncture habitats the size of a pinhead, yet deadly in their speed. The human body can adapt, but it cannot conquer. It must coexist. Every breath, every sunrise seen through a window of reinforced glass, is a reminder that life in space is both miracle and defiance. Despite these perils, humanity persists, because the dangers of space are not deterrents. They are teachers. Each challenge forces us to innovate, to evolve, to become stronger than the limits of our biology. The radiation that threatens us spurs the development of new materials. The isolation that haunts us inspires new psychological strategies. Even failure becomes fuel for progress. This struggle between fragility and determination defines the next phase of exploration. To survive in space, humanity must not only build stronger machines, but also stronger minds. The void is merciless, but it also offers clarity. It strips away illusion, leaving only what is essential. And perhaps that is space's greatest gift. It reveals, with every challenge, what it truly means to be human. Every era of exploration is defined by its tools. The compass guided sailors across uncharted oceans. The telescope opened the heavens to human eyes. The rocket shattered the barrier of gravity itself. But as we move from exploration to habitation, from visiting space to living in it, our tools must evolve beyond anything humanity has ever built. The technologies of tomorrow will not simply carry us to new worlds. They will sustain us there. The foundation of every spacefaring civilization begins with propulsion, the art of movement through the void. For over half a century, chemical rockets have been our engines of exploration, burning liquid hydrogen and oxygen to produce thrust. They are powerful but inefficient. To reach Mars or beyond, we will need more than explosive fuel. We will need endurance. That is where electric and nuclear propulsion come in. Ion thrusters, already used on satellites and probes like Dawn and Bepi-Colombo, offer unmatched efficiency by accelerating charged particles to extreme velocities. Though their thrust is gentle, they can operate continuously for months, gradually building incredible speed. For crewed missions, hybrid systems, combining chemical rockets for liftoff and ion engines for interplanetary travel, may become the norm. Even more ambitious are nuclear thermal rockets, capable of heating hydrogen with fission reactors to deliver twice the efficiency of conventional fuel. They could cut the journey to Mars from 9 months to just 4 or 5, reducing radiation exposure and resource costs. NASA and DARPA are already developing prototypes under the Draco program, with test flights expected in the coming decade. But propulsion is only the beginning. Once we arrive, we must create life from nothing. That means mastering energy generation, resource extraction, and closed-loop sustainability. The concept of in-situ resource utilization, ISRU, using what already exists on other worlds, is the cornerstone of off-Earth survival. On the Moon, that means harvesting oxygen from regolith and extracting water from polar ice. On Mars, it means pulling carbon dioxide from the air to create methane fuel through the Sabatier process, a method already being tested by NASA's MOXIE experiment aboard the Perseverance rover. With ISRU, every mission becomes lighter, cheaper, and more independent, the difference between a temporary outpost and a self-sufficient colony. Energy, too, will define the rhythm of life beyond Earth. Solar arrays, already proven on the ISS, will stretch across lunar plains and Martian deserts, feeding power into vast networks of batteries and supercapacitors. Compact nuclear reactors, such as NASA's Kilopower system, promise continuous energy for habitats, rovers, and factories. In the future, fusion power, the same process that lights the sun, may make interplanetary civilization truly limitless. Yet technology's role goes beyond survival. It extends to transformation. The next generation of habitats will not be static domes, but living systems. Self-repairing materials made from bacteria, bioregenerative life support systems, and 3D printed architecture capable of evolving with its environment, all will redefine how we think of home. Advances in robotics and artificial intelligence are already rewriting the rules of exploration. On Mars, autonomous drones and rover swarms can map terrain, build structures, and mine resources long before humans arrive. AI systems will monitor air quality, radiation levels, and energy use, learning and adapting faster than human operators could from Earth. The future astronaut may not just pilot machines, they may live alongside them as partners. Communication will be another frontier. The vast distances between worlds make real-time interaction impossible, but quantum communication and laser-based transmission promise a new kind of network. Faster, more efficient, and secure from interference. In time, these links could evolve into the backbone of an interplanetary internet, connecting Earth, the Moon, Mars, and beyond. Even transportation between celestial bodies is undergoing a revolution. Concepts like space elevators, orbital tethers, and lunar mass drivers could reduce the cost of launching materials from low-gravity worlds. SpaceX's Starship, if it fulfills its promise, will become not just a rocket, but a reusable cargo vessel, the equivalent of the ships that once bridged the old world and the new. Medical innovation will also become essential. Away from Earth's hospitals, colonists must rely on telemedicine, AI diagnostics, and even bioprinting, the creation of human tissue and organs from 3D printers. Scientists are experimenting with drugs and gene therapies that could protect astronauts from radiation and bone loss. In the future, humanity may not only adapt to space through machines, but through evolution, biological or engineered. Still, for every problem technology solves, it creates another. Automation raises questions of control and dependency. Artificial intelligence could make life safer, but also blur the line between human decision and machine autonomy. And the more we depend on complex systems, the greater the risk of catastrophe should they fail. Yet these are the paradoxes of progress. The same fire that lifted us from the savannah now pushes us toward the stars. Each invention, from reusable rockets to life-sustaining habitats, is another step in the construction of a civilization that can outlast its planet of origin. The dream is no longer merely to explore space. It is to build within it, to turn the void into a home, and to extend the reach of life itself. Because technology, at its best, is not a collection of machines, it is a reflection of our will to survive. And as we forge these tools, we are not just building rockets and reactors. We are building the next chapter of human existence. Every great era of exploration has been driven not only by curiosity but also by economy. The voyages of the 15th century were not purely quests for knowledge. They were searches for new routes, resources, and wealth. The same truth now echoes in the modern age of space. Beyond the poetry of discovery lies a practical, undeniable question. How do we pay for the stars? For decades, space was the realm of governments. Vast budgets, national pride, and scientific goals that justified extraordinary expense. The Apollo missions, adjusted for inflation, cost over $150 billion. The International Space Station, a marvel of engineering and diplomacy, has consumed more than $100 billion over its lifetime. Such efforts were never profitable. They were investments in prestige and progress. But the 21st century has introduced a new model, one where space is not just exploration but enterprise. The rise of private industry has rewritten the rules of the cosmos. SpaceX, Blue Origin, Rocket Lab, and other companies have proven that commercial innovation can achieve what once required entire nations. By perfecting reusability and streamlining production, they have slashed the cost of reaching orbit. What once cost tens of thousands of dollars per kilogram now costs a fraction. The barrier between spacefaring nation and private company has all but vanished. This economic revolution has created a new ecosystem, a marketplace in orbit. Communication satellites, once government projects, are now cornerstones of global commerce. The next step is far more ambitious, transforming the Moon, Mars, and the asteroid belt into centers of production and trade. The Moon will likely become the first industrial hub beyond Earth. Its low gravity makes it ideal for launching cargo deeper into the solar system, while its soil contains metals such as iron, titanium, and aluminum. More importantly, its polar ice can be refined into water and fuel. Lunar refueling stations, gas stations for interplanetary travel, are already being studied by NASA and private firms. With them, spacecraft could travel farther and cheaper than ever before. But the true gold rush of space may lie among the asteroids. These wandering rocks, remnants of the early solar system, are rich beyond imagination. A single metallic asteroid, such as 16 Psyche, contains enough nickel, cobalt, and precious metals to dwarf Earth's entire economy. Mining them will not be easy, but the incentive is staggering. Companies like Planetary Resources and Transastra are developing robotic miners that could harvest these materials, refining them in orbit or redirecting small asteroids closer to Earth for processing. In this vision, space becomes not just a destination, but a supply chain, a network of trade routes stretching from Earth's orbit to Mars and beyond. Imagine fleets of autonomous cargo ships ferrying metals, water, and fuel between celestial outposts. Solar energy harvested in space could be beamed down to Earth through microwave transmission, powering cities without pollution. Factories in orbit could produce materials impossible to make under gravity, perfect crystals, ultra-pure pharmaceuticals, or fiber optics of extraordinary quality. These ideas, once science fiction, are now under serious study. Japan's JAXA has already tested wireless energy transmission from orbit. Private companies are exploring orbital manufacturing of semiconductors and biological materials. As costs drop and technologies mature, space industry will evolve from experiment to economy, the next great revolution after the digital age. Yet, with opportunity comes tension. Who owns the moon's resources? Can a corporation claim an asteroid? The Outer Space Treaty of 1967 forbids any nation from declaring sovereignty over celestial bodies, but it says little about private companies. In recent years, the United States, Luxembourg, and the United Arab Emirates have passed laws allowing their corporations to claim extracted materials, effectively opening the door to commercial space mining. Critics argue that this could create a new kind of colonialism, where wealth and control are concentrated among a few powerful entities. To prevent this, international cooperation will be crucial. Just as the Antarctic Treaty preserved a continent for peaceful research, new space accords may need to ensure that the solar system's resources are used for the benefit of all humanity. The challenge is to balance profit with ethics, innovation with responsibility. Without such balance, the next frontier could repeat the mistakes of the old: exploitation, inequality, and conflict under a new sky. Meanwhile, entire industries are emerging around space tourism, construction, and data. Companies like Axiom Space plan to build commercial space stations, offering laboratories, entertainment, and even luxury accommodations in orbit. Virgin Galactic and Blue Origin are selling suborbital flights, brief journeys to the edge of space, where passengers experience weightlessness and see the curve of Earth. What was once the privilege of astronauts is becoming the experience of the wealthy. Some see this as trivial, others as transformational. The early tourists of space are like the first airline passengers of the 20th century, a small group paving the way for a global industry. As technology improves and prices fall, space travel may one day become as routine as flying between continents. And beyond tourism lies another form of value, one that cannot be measured in currency. The expansion into space will generate not only jobs and resources but also knowledge. Every invention made for survival beyond Earth, from renewable energy systems to closed-loop recycling, will find its way back home, reshaping industries and economies across the planet. Space exploration has always paid dividends, just not in the form of gold. In the end, the economics of space is not about wealth alone. It is about continuity, ensuring that human civilization can grow without consuming its birthplace. The universe offers abundance, but it demands ingenuity. The next economy will not be built on extraction, but on adaptation, the ability to create balance between what we take and what we sustain. As Earth's markets look upward, one truth becomes clear. The future of prosperity may not lie in new lands or technologies, but in the stars themselves. And this time, the wealth we seek may not just be material, but the survival of our species. When humanity first looked to the stars, we did so with a single voice, one of wonder. But as soon as we began to reach for them, politics followed. Every rocket launch, every flag planted on lunar soil, carried more than scientific ambition. It carried power, pride, and the quiet assertion of dominance. In space, as on Earth, cooperation and competition are inseparable. The first space age, from Sputnik to Apollo, was defined by rivalry. The United States and the Soviet Union turned the cosmos into a stage for ideological performance. To reach orbit, to send a human into space, to step onto another world. Each was a statement of supremacy. Yet, ironically, it was this competition that propelled progress. The fear of being left behind pushed humanity forward faster than peace ever had. But as the Cold War ended, a new model emerged. The construction of the International Space Station, ISS, in 1998, symbolized a shift from national rivalry to global partnership. Built and operated by the United States, Russia, Europe, Japan, and Canada, it became the largest collaborative engineering project in human history. Astronauts who once trained to fight for their nations now shared air, food, and laughter in orbit. The ISS proved that space could unite rather than divide. Still, cooperation in orbit is fragile. As new powers rise, the balance of control shifts once again. The 21st century has ushered in a second space race, not between two superpowers, but among many actors: governments, corporations, and private individuals. The United States, China, Russia, India, and the European Union each pursue their own ambitions, while private companies like SpaceX and Blue Origin blur the lines between public mission and private profit. China's Chang'e program has established it as a dominant force in space exploration. With successful lunar landings, rover deployments, and the construction of the Tiangong space station, China has demonstrated both capability and independence. Its stated goal, a permanent lunar base by the mid-2030s, parallels NASA's Artemis program, creating an inevitable rivalry. Officially, both nations speak of peaceful development, but behind the language of cooperation lies a strategic contest for influence and resources. India, too, has entered the race, achieving historic milestones such as the Chandrayaan-3 lunar landing near the Moon's South Pole and the Mangalyaan Mars mission. These successes have elevated India from regional player to global pioneer, proving that space is no longer the playground of a few wealthy nations. The universe, once dominated by superpowers, is slowly democratizing, though the rules remain unwritten. And then there are the private empires. SpaceX's Starlink network already blankets the planet with thousands of satellites, providing global internet coverage and, inadvertently, geopolitical leverage. In conflict zones and natural disasters, access to this network can shape outcomes, giving one company influence once reserved for governments. Blue Origin, Axiom Space, and countless startups hold similar power in emerging markets like lunar logistics, asteroid mining, and orbital transport. The question arises: who governs the governed? When the frontier is infinite, international law lags far behind innovation. The Outer Space Treaty of 1967, written at the dawn of the first space age, declared that space shall be the province of all mankind. It forbids national ownership of celestial bodies, the placement of nuclear weapons in orbit, and the militarization of space. But it says little about corporate activity, resource extraction, or private infrastructure. The Artemis Accords, led by the United States and signed by over 30 nations, attempt to fill that gap, setting principles for transparency, interoperability, and peaceful use. Yet major powers like China and Russia have not joined, seeing them as instruments of American dominance. This legal fragmentation risks turning the solar system into a patchwork of competing jurisdictions, a celestial version of colonial Earth. If one nation claims exclusive access to lunar ice or an asteroid's metals, what prevents another from doing the same? Without global consensus, the race for the stars could quickly become a race for control. Military interests only complicate the picture. The establishment of the U.S. Space Force in 2019 marked the formal recognition of space as a potential theater of warfare. Anti-satellite weapons, tested by several nations, have already demonstrated the ability to destroy orbital targets, creating dangerous debris fields that threaten civilian satellites and astronauts alike. The weaponization of space, once unthinkable, is now a matter of strategic planning. Yet amid this tension, cooperation still flickers like a fragile flame. Joint missions, data-sharing agreements, and multinational research efforts continue to link humanity's cosmic ambitions. The reality is that no single nation can conquer the stars alone. The cost, the complexity, and the danger demand collaboration. Even the most powerful countries will need each other to survive in the harsh vacuum beyond Earth. Space politics mirrors the paradox of human nature itself, our dual capacity for unity and division. We build international stations in orbit, yet compete for dominance beneath them. We share data on Mars exploration, yet guard our technologies with secrecy. We dream of humanity as one species, yet still draw borders across the void. Perhaps this is inevitable. The stars are not utopian. They are mirrors. They reflect who we are: ambitious, conflicted, and bound by our own history. The real question is not whether nations will compete in space, but whether they can learn to compete without destroying the possibility of coexistence. For in the end, no matter how far we go, the cosmos belongs to no one and everyone alike. And if humanity fails to understand that, the greatest frontier may also become its greatest divide. Every breakthrough in space sends a tremor through Earth. The rockets that rise from desert launch pads or island spaceports may seem distant from daily life, but their echoes reach into every corner of human civilization. Each new discovery, each mission, reshapes economies, politics, and even culture, revealing that space exploration is not just an endeavor of the few, but a force that alters the destiny of the many. In 2025, when NASA's Artemis II mission prepares to send humans around the moon for the first time in half a century, millions will watch. But the significance will extend beyond inspiration. The event will spark new investments in science and engineering, new jobs in aerospace, and a global surge of technological ambition. Nations that once saw space as distant will begin to see it as essential, not just for prestige, but for participation in a new world economy that begins above the atmosphere. From Africa to Southeast Asia, emerging economies are building their own space programs. Nigeria, the Philippines, and Vietnam now operate satellites for communication and weather tracking, reducing dependency on foreign systems. Rwanda, Ghana, and Kenya are training engineers for orbital technology, seeing space as a path to independence and innovation. Small nations with small budgets are finding ways to join the cosmos through collaboration, private partnerships, and shared data networks. At the same time, space is redefining the modern balance of power. Satellite constellations like Starlink and OneWeb are not only transforming internet access but also reshaping geopolitics. During conflicts and natural disasters, these networks provide critical communication, sometimes faster than governments can act. Control of orbital infrastructure now means control of information, and information, as always, is power. The ripple extends into the global economy. Demand for new materials, advanced electronics, and reusable rocket components has driven a manufacturing renaissance in several countries. Entire industries, robotics, renewable energy, and artificial intelligence have found new purpose in supporting the challenges of off-world expansion. The space industrial complex has become the 21st century's equivalent of the railroad or the internet, a vast network binding nations through technology, investment, and shared destiny. But the cultural ripple is perhaps even greater. For the first time since the Apollo era, humanity is reimagining itself not as a collection of nations, but as a single species with a shared horizon. Films, literature, and art are shifting from the despair of dystopia to the hope of expansion. Writers speak of multiplanetary identity, philosophers debate the ethics of terraforming, and theologians wonder what faith means under another sky. Even fashion and design reflect the influence: sleek materials, minimal aesthetics, and the subtle motif of stars woven into everyday life. Education is changing, too. Schools across the world are reviving interest in physics, mathematics, and engineering. The new generation is growing up not under the shadow of old wars, but under the glow of new worlds. For them, the idea of living on the moon or Mars is not fantasy. It is a career path. Humanity's imagination is shifting, and with it, our sense of what is possible. Still, not all ripples are benign. The same technologies that open the heavens also deepen inequalities on Earth. The commercialization of orbit favors wealthy nations and corporations. While private firms launch hundreds of satellites, poorer regions struggle to afford basic connectivity. The new space economy risks mirroring or even amplifying the divides it promised to overcome. Environmental concerns add another layer of consequence. Thousands of satellites orbiting Earth contribute to the growing problem of space debris, fragments of metal hurtling at 28,000 kilometers per hour. Each piece is a potential bullet that could destroy spacecraft or endanger astronauts. The Kessler syndrome, a chain reaction of collisions, threatens to turn low Earth orbit into an impassable minefield. Governments and companies now race to create cleanup technologies, robotic nets, magnetic tethers, and atmospheric drag systems, in a desperate effort to prevent catastrophe. Meanwhile, back on Earth, climate scientists are finding unexpected allies in the space community. Satellite data provides unparalleled insight into weather systems, ocean currents, and deforestation. Without it, our understanding of global warming would be blind. Space exploration, once seen as an indulgence, is now essential for protecting the planet it once sought to leave behind. In laboratories and startups, new connections emerge between the cosmic and the terrestrial. Solar power satellites may one day beam clean energy to Earth. Technologies for recycling and resource efficiency, designed for Mars bases, are being adapted for sustainable cities here at home. Even medical advances, developed to treat astronauts' bone loss or muscle atrophy, are improving healthcare for millions. The ripple effect is not just economic, it is humanitarian. And yet, beneath this growing interconnectedness lies a subtle shift in humanity's collective psychology. The more we reach outward, the more we begin to question what it means to belong. When images of Earth from orbit show a world without borders, old divisions seem less permanent. Philosophers speak of the overview effect, the profound realization, reported by astronauts, that from space, all of humanity shares a single fragile home. As this vision spreads through films, broadcasts, and education, it begins to erode the illusions of separation that have defined human history. The new space age is not a chapter isolated from Earth's story. It is its continuation. Every rocket launch writes both a promise and a warning, that our destiny lies among the stars, but our conscience must remain with the world we came from. The ripple of exploration touches everything: economies, ideologies, identities, and whether it leads to harmony or division depends on what we choose to learn from it. We are entering a time when what happens above the atmosphere will shape life below it. The space age is no longer about distance. It is about connection. Every orbit, every transmission, every discovery is a reminder that humanity's story has outgrown one world, and that our choices in the coming decades will determine whether that story becomes one of expansion or extinction. Every generation believes its frontier is unique, but history often whispers otherwise. The story of humanity's expansion into space, the dreams, the conflicts, the ambitions, mirrors every great journey that came before it. From the first oceanic voyages to the colonization of new continents, the same pattern repeats: discovery, wonder, exploitation, and adaptation. The stars may be new, but the human story is old. 500 years ago, the age of exploration redrew the map of the world. European ships, guided by rudimentary instruments and unyielding will, crossed oceans once thought impassable. They brought with them trade, culture, and knowledge, but also conquest, disease, and domination. The seas, once barriers, became bridges between civilizations. Yet those bridges often carried more than curiosity. They carried power. Today, the cosmos plays the same role the oceans once did. It is the next great expanse, the ultimate unknown. The vessels are different, steel and plasma instead of wood and sail, but the motivations are strikingly familiar. The quest for resources, for security, for destiny. As nations and corporations race to claim their place among the stars, echoes of colonial language emerge. Frontier, outpost, settlement, ownership. It is a reminder that even as we leave Earth, we bring our history with us. The moon, with its barren beauty, may become humanity's first colony, not in the imperial sense, but as a shared foothold in the cosmos. Yet already questions arise about sovereignty, profit, and control. Who governs a lunar base built by multiple nations? Who regulates a private company mining its soil? The Artemis Accords attempt to answer these questions by promoting transparency and cooperation, but their framework depends on voluntary participation. Like the early maritime treaties of the 17th century, they rest on mutual trust, a fragile currency in a competitive age. Mars, too, evokes historical parallels. Its potential settlers will face the same hardships as pioneers once did: isolation, scarcity, and the constant threat of failure. The difference is that they will do so millions of kilometers from home, with no rescue possible. Every colony on Mars will be a test of endurance. A new Plymouth, a new Jamestown, forged in red dust instead of wilderness. And just as those early colonies shaped new cultures, Mars will likely give rise to a civilization unlike any before it. Historians see in these parallels both warning and wisdom. The colonization of the New World brought scientific progress and cultural exchange, but it also brought devastation to indigenous peoples and ecosystems. The danger is not that we will repeat these mistakes exactly. There are no natives on Mars, but that we will repeat the mindset, the belief that expansion itself is justification. If the cosmos becomes another arena for extraction and exploitation, humanity's destiny among the stars may resemble its past more than its future. Yet there is another lesson in those old voyages, one of transformation. Exploration changes the explorer. The sailors who left Europe did not return the same. They brought new ideas, new foods, and new philosophies. Contact with the unknown reshaped their sense of what the world could be. Space, too, has that power. To see Earth as a fragile sphere hanging in darkness is to understand, perhaps for the first time, how small we truly are and how connected. Every photograph of Earth from space, from Apollo 8's Earthrise to the Voyager 1's pale blue dot, has carried that message, that our divisions are illusions, our borders invisible. These images have inspired environmental movements, humanitarian efforts, and a growing recognition that our planet is not a possession, but a shared responsibility. Space exploration, at its best, does not divide, it unites through perspective. The ancient explorers sought to map the physical world. The new explorers seek to map the limits of existence itself. Their challenges are not only technical but ethical. Should humanity terraform another planet, altering its pristine environment for our comfort? Should we seed other worlds with life, and if we do, are we creators or conquerors? These questions echo the debates of centuries past, when humans first asked whether they had the right to reshape the lands and lives they discovered. As we push further into the solar system, our history becomes both guide and warning. The same courage that drove ships across unknown seas now propels rockets into the void. But courage without conscience is dangerous. The true challenge of this new age is not how far we can go, but how wisely we can travel. If history teaches anything, it is that exploration always reveals more than new worlds. It reveals ourselves. The way we treat the moon, Mars, and the heavens beyond will reflect who we have become as a species. Whether we choose domination or stewardship, exploitation or coexistence, will define the legacy we leave, not just on Earth but across the stars. For one day, future historians, born perhaps on the red sands of Mars or beneath the silver domes of the moon, will look back at this moment as we now look at the voyages of old. They will see it as the dawn of something vast, the age when humanity stepped beyond its cradle and began to write the next chapter of its story. And the question they will ask is the same one that echoes through every era of discovery. Did we learn from our past before we reached for the future? Every story of exploration eventually reaches a moment that changes everything. A discovery so unexpected that it forces humanity to question not just where we are going, but why. In the modern age of space, that turning point may not come from the moon or Mars, but from farther away, from the stars themselves. In late 2037, a small array of radio telescopes in Chile's Atacama Desert detected something peculiar. It was faint, a narrowband signal from a seemingly empty region between two distant stars, Tau Ceti and Epsilon Eridani. At first, scientists dismissed it as interference, perhaps from a satellite or an echo from Earth's own transmissions. But as the weeks passed, the signal returned regular, precise, and unmistakably structured. It wasn't a message, at least not in any language we know. It was a pattern, mathematical, recursive, built on prime numbers and golden ratios. The kind of order nature rarely creates by accident. For the first time in history, humanity faced a possibility it had imagined for centuries but never proven: that we are not alone. The discovery ignited both wonder and fear. Within days, social media erupted with theories, documentaries, and conspiracy claims. Governments held emergency briefings, while scientists urged caution. The SETI Institute, which had searched for extraterrestrial signals for decades without success, verified the detection but refrained from declaring contact. "It's a phenomenon," they said, "but we don't yet know its source." NASA, the European Space Agency, and private observatories around the world turned their instruments toward the same coordinates. They found no visible object, no planet, no craft, not even a cloud of debris. Only the pulse, repeating every 37 hours, perfectly stable. It did not drift or decay. It simply persisted, like a clock ticking across the void. Then came a second anomaly. The Chinese Fast Telescope, the largest in the world, reported a faint reflection of the same signal bouncing off Earth's upper atmosphere. It wasn't directed from space alone. It was interacting with our planet. For a brief moment, humanity felt both awe and vulnerability, as if the universe had turned its gaze upon us. While scientists debated its origin, a quiet race began behind closed doors. Intelligence agencies sought to determine whether the signal might be human-made, perhaps a classified transmission or even a weapon. Tech corporations scrambled to analyze the data with AI systems capable of decoding hidden patterns. Religious leaders, meanwhile, saw prophecy. Philosophers saw proof of destiny. For the public, it was a moment of global unity unlike any since the first moon landing. People gathered in parks and on rooftops to listen to the faint hum rebroadcast on radio waves. In those shared silences, humanity seemed, for a fleeting instant, to remember its common identity. A species small and curious beneath an infinite sky. The phenomenon also reshaped the direction of space exploration. Funding for deep space missions surged. The search for life, once a scientific niche, became a planetary priority. Space agencies announced a new generation of telescopes and probes, designed not merely to observe the universe but to listen. The question that had haunted human imagination for millennia, "Are we alone?" was no longer philosophical. It was empirical. And yet, amid the excitement, skepticism endured. Some astrophysicists warned that natural explanations might still exist: pulsars, magnetars, or unknown cosmic events. Others cautioned that even if the signal were artificial, we might never understand its meaning. After all, intelligence does not imply communication. What if the signal was not meant for us? What if we were eavesdropping on something far older and far greater? Weeks turned into months. The signal's rhythm shifted subtly, but enough to suggest modulation. It began to encode variations that could represent data, perhaps even a sequence. Computer models translated the changes into a series of geometric forms: spirals, lattices, and branching patterns reminiscent of biological growth. It's as if, one scientist remarked, the signal is alive, not in the organic sense, but as a system that learns and evolves. And then, as mysteriously as it began, it stopped. The silence that followed was deeper than the signal itself. For the first time in decades, the night sky felt different, no longer a void, but a presence waiting to be understood. Around the world, humanity held its breath, uncertain whether it had just witnessed the first conversation with the cosmos or merely a cosmic coincidence. In the months that followed, theories multiplied. Some believed the signal was a test, a simple ping to measure intelligence across the galaxy. Others claimed it was a warning or an invitation. A few argued it was us, a reflection of humanity's own transmissions bouncing back from an interstellar mirror. Whatever the truth, one thing was undeniable. The discovery had changed us. Nations that once competed for dominance in space now found themselves sharing data, pooling resources, and coordinating missions in unprecedented collaboration. For the first time, humanity was united not by fear of one another, but by wonder of something greater. The search for the signal's source continues. New probes, powered by ion engines and nuclear reactors, are being prepared to venture toward its origin. The mission is called Aurora, humanity's first interstellar attempt, a journey that will take generations. And as engineers assemble its components under the bright lights of clean rooms, a single phrase has begun to circulate among them. Written on white boards, whispered in corridors, engraved on a plaque to be sent aboard the ship. If someone is out there, we are listening. The signal may have ended, but its echo remains. Not in the stars, but in us. It reminds humanity that exploration is not only about reaching new worlds, but about understanding the vastness of what we still do not know. Perhaps the true turning point was never the discovery itself, but the realization that the universe had finally answered our silence with its own. When the Aurora mission launched from Earth in 2048, it marked the beginning of a new epoch, the moment humanity transformed from a planetary civilization into an interstellar one. No longer confined to a single world or even a single system, we began to stretch the boundaries of our existence across light years. It was not conquest, nor escape. It was continuity, the next logical step in the story of a species that had always refused to stay still. The Aurora was unlike any vessel ever built. Its fusion drive glowed with the light of artificial stars, its hull composed of self-healing alloys designed to endure centuries of travel. Inside, thousands of sensors and autonomous systems worked in silence, their only purpose to protect the most precious cargo ever sent into space. The essence of humanity. Not just data and DNA, but voices, art, languages, and music, an archive of who we were, encoded in crystal lattices and quantum memory. The journey to the signal's origin, a star 12 light-years away, would take more than a human lifetime. But the crew that embarked on it accepted this truth with quiet resolve. Some were born aboard generation ships orbiting Mars. Others had lived in lunar colonies or on orbital habitats. For them, Earth was not a home to leave behind. It was a myth, a memory passed down in stories. The cradle of humanity had already become a legend among its children. Back home, the solar system itself was changing. The moon had evolved into a network of settlements and refineries, glowing with the soft light of fusion towers. Mars had grown cities, transparent domes stretching across valleys, green with hydroponic forests and canals of melted ice. The asteroid belt had become a lattice of industry, where autonomous harvesters mined metals and water for the colonies beyond. Humanity had not just survived. It had flourished. Everywhere, there was motion. Ships ferrying goods and people between worlds, satellites pulsing in orbital networks, and vast stations drifting at the edges of the outer planets. Titan's methane seas hosted floating laboratories. Europa's frozen crust was being drilled to search for microbial life. Even the darkness between planets, once feared, had become familiar, mapped, traversed, domesticated by courage and invention. The Aurora was humanity's first interstellar messenger, but it was not alone for long. Within a decade, new vessels followed: Endeavour, Horizon, Silva, Okeanos. Each carried explorers, scientists, and settlers, seeds of civilization cast into the galactic wind. These were not warships or colonizers, but ambassadors of life itself, carrying ecosystems in miniature. Algae gardens, microbial biomes, and human embryos in cryostasis. The vision was not of conquest, but of continuity. Humanity's expansion was no longer about territory or ownership. It was about resilience, the will to endure across time and distance. On every new world, from the volcanic moons of distant giants to the icy plains of exoplanets, colonies took root like fragile seedlings. Artificial atmospheres shimmered beneath transparent domes. Robots built foundations, while children born under foreign suns learned to call two worlds home. The one they lived on, and the one they came from. And yet, with every success came reflection. The more humanity expanded, the more distant Earth became, not just in space but in memory. For many born in the colonies, Earth was a place they had never seen, a blue sphere from old photographs, more mythical than real. Museums on Mars preserved ancient soil in glass cases, a reminder of where everything had begun. Teachers spoke of oceans that once covered a world, of forests that breathed air freely. To the young, it seemed almost impossible that such abundance had ever existed. Still, Earth remained sacred, the origin, the heart. Every colony maintained a ritual connection. Broadcasts of Earth's skies, celebrations timed to its solstices, echoes of its languages woven into music and speech. The word human itself expanded, no longer bound to a single gravity or atmosphere. The meaning of "we" began to include those who had never walked on the planet that birthed the word. Then came the first transmission from Aurora. After decades of silence, a faint signal returned, distorted, fragmented, but unmistakably human. The ship had reached its destination. The data contained spectral readings of an exoplanet orbiting a small yellow star. It was rich in organic compounds, methane, nitrogen, carbon, and its atmosphere shimmered with patterns that could not be explained by geology alone. The message ended with a phrase, encoded in binary, "We are not the first." The words ignited a wave of speculation and awe. Scientists debated their meaning. Had Aurora found traces of alien technology, or the ruins of an ancient civilization? Or was it a philosophical statement from the crew, a reflection on the continuity of life in the cosmos? No one knew for certain, but the implication was clear. The universe was no longer empty. The era of expansion had entered a new phase. Humanity was no longer exploring for survival alone, but for understanding. Colonies became academies. Mining stations became observatories. The pursuit of life and meaning replaced the pursuit of territory. The same curiosity that once drove explorers across seas and planets now propelled civilizations across light years. And yet, amid the triumph, a quiet fear lingered. What if humanity's spread was not evolution, but dilution? What if, in reaching so far, we lost the unity that once defined us? The farther we traveled, the more fragmented our identity became. A child born under the orange sky of Mars might see themselves as Martian. One raised on Titan, as a citizen of the outer system. The word Earthling began to fade from language, replaced by something broader, Terran, Solarian, human universal. But perhaps this, too, was progress, the gradual merging of diversity into something new. The species that once warred over continents had become a species that built worlds. The instinct that once fueled division had become the same force that ensured survival. Humanity had not escaped its past. It had evolved beyond it. And as the aurora's faint signal continued to whisper across the cosmos, one truth became clear. The stars were not our destination. They were our reflection, vast, patient, and waiting for us to understand. By the time the aurora's message reached Earth, humanity had already become something larger, and perhaps something stranger. The solar system was no longer a collection of distant worlds, but a living network. Voices traveled between the planets with the same ease that radio once crossed oceans. Colonies pulsed with their own rhythms, their own art, and even their own philosophies. Humanity had scattered, and yet, in its scattering, it began to see itself more clearly. For centuries, our ancestors gazed at the stars and asked who we were. Now, surrounded by them, we ask the question again, but differently. To be human once meant to belong to Earth. It meant blue skies, oceans, gravity, and history. But what does it mean to be human when your sky is copper red, your air is manufactured, and your ancestors lived under another sun? On Mars, the question is answered in architecture. Cities curve beneath transparent domes that filter radiation but let through the light of two moons. Streets are narrow, efficient, designed to conserve heat. Life is deliberate, every drop of water, every breath accounted for. Martian culture values precision, cooperation, and endurance. Art there is minimal, geometric, born from the necessity of survival. To be Martian is to live with intention, to measure beauty by balance and efficiency. On the moon, humanity expresses itself in light. Lunar colonies lie in eternal contrast, harsh darkness against blinding day. Festivals of illumination mark the end of each 2-week night. Glowing sculptures and holographic gardens rise from the regolith. The moon has become a sanctuary for reflection and art, a place where silence and solitude are sacred. Lunar dwellers see themselves as keepers of memory, curators of humanity's origin. Meanwhile, in the vast orbital habitats around Earth and Venus, life has taken a different turn. Floating cities spin gently to simulate gravity. Gardens stretch along the inner walls of giant cylinders, lit by mirrors that capture distant sunlight. These stations are laboratories of civilization, places where democracy, technology, and biology intertwine. Children grow up knowing the names of constellations as neighbors, not mysteries. Every colony, every settlement, has evolved its own answer to the same question. What does it mean to be human when humanity is everywhere? Philosophers of the outer colonies speak of a concept called the continuum, the idea that humanity is no longer a single species tied to one form, but a spectrum of existence unified by consciousness and memory. Genetic engineering, cybernetic augmentation, and adaptive evolution have blurred the boundaries of biology. Some humans breathe methane on Titan. Others live in zero gravity, their bones reshaped by life in orbit. Yet they all share something ancient, the same curiosity, the same longing to reach beyond themselves. This diversity, once feared, becomes a kind of strength. The more humanity changes, the more it reflects the universe itself. Vast, varied, and evolving. The stars have not made us less human. They have revealed what humanity truly is. A process, not a form. And yet, amid all progress, a shadow remains. The further we expand, the more fragile our unity becomes. Messages between colonies take hours, days, sometimes weeks to arrive. Ideas diverge. Values shift. 1,000 interpretations of Earth emerge. Paradise, myth, warning, home. Some call it the lost world. Others, the source. For many, it is simply a story told by ancestors. Back on Earth, still vibrant, still home to billions, humanity watches its children grow away. The planet has become a cradle-turned museum. Cities once threatened by climate collapse now thrive under global stewardship. Vast networks of orbital mirrors regulate temperature. Forests reclaimed deserts. The oceans breathe again. Earth has learned from its past, even as its descendants surpass it. From this blue sanctuary, scientists, philosophers, and historians debate the meaning of the new age. Has humanity transcended evolution, or merely accelerated it? Are we still one species, or many? And if we are many, what binds us, biology, history, or memory? The Aurora's final transmission offered no answers, only a reflection. Embedded in its data, encrypted within the images of distant skies, was a final phrase, discovered years later by a team of linguists on Luna-based Theta. To understand the infinite, one must first understand oneself. It became a creed across the colonies, inscribed in airlocks, classrooms, and temples. Pilots whisper it before launches. Children learn it as a prayer. It is both reminder and warning that in the pursuit of the stars, we must not lose sight of the one universe we already inhabit, the universe within. Technology has taken humanity far. Artificial intelligence manages interplanetary economies. Quantum networks link worlds across light years. Yet every great invention circles back to the same truth. Machines can expand our reach, but only consciousness gives us purpose. In the end, the cosmos is not defined by stars or galaxies, but by the awareness that looks upon them. Perhaps that is the real meaning of being human. Not our shape or our home, but our capacity to wonder, to look into the dark and see not emptiness, but possibility. The great reflection is not the end of our journey. It is the moment we realize that the journey itself, endless, uncertain, magnificent, is what makes us who we are. And so, humanity continues to build, to explore, to listen. For though the stars stretch beyond imagination, we are no longer afraid of their silence. We understand now that every flicker of light out there is also within us, a reminder that no matter how far we travel, we carry the cosmos inside. The stars have always been more than lights in the sky. They have been mirrors reflecting who we are, what we fear, and what we dare to become. Now, as humanity stands dispersed across a dozen worlds, connected by light and distance, the cosmos no longer feels infinite. It feels alive, and we are part of it. The aurora's legacy still lingers in every colony, every classroom, every whispered story. This message, "We are not the first," has become both inspiration and mystery. Scientists continue to debate its meaning, but for most, it no longer matters whether it referred to alien civilizations or to something deeper. It has become a metaphor for continuity, a reminder that the story of life did not begin with us, and it will not end with us. From the outer systems, new signals have been detected, faint, rhythmic, patterned. Some believe they are natural, others think they may be echoes of aurora's transmission, refracted through spacetime. But one thing is certain, we are listening differently now. No longer as a single, frightened species on one fragile planet, but as a civilization that has learned patience. We no longer demand answers from the universe. We ask questions and accept its silence as part of the conversation. Across the solar system, humanity thrives in diversity. On Mars, children walk under domes of tinted glass, learning to grow crops in red soil. On the moon, poets carve verses into basalt, read only by starlight. In orbit, engineers tend to vast solar rings that feed energy back to Earth, ensuring that the cradle of life never darkens again. The outer colonies, orbiting icy moons and drifting habitats, have begun to think of themselves as stewards of something greater, not conquerors of the cosmos, but caretakers of possibility. Earth itself, though quieter, remains the heart. Its cities glow softly under skies that once burned with pollution. Reforested continents and restored oceans testify to lessons learned too late but acted upon nonetheless. The planet that once feared its own destruction has become a symbol of balance, proof that even in error, humanity can choose redemption. Each year, on the anniversary of the first lunar landing, a signal is broadcast from every colony, every station, every ship, a synchronized transmission across the entire network of human space. It begins with silence, followed by a single tone, the same frequency as the mysterious pulse once detected from beyond Tau Ceti. Then, in thousands of languages and dialects, the same words are spoken. We are here. We remember. The ritual is more than commemoration. It is a declaration, a quiet promise that wherever we go, we will not forget the world that gave us meaning. That no matter how vast the horizon becomes, Earth will remain the compass of our identity. But the future, as always, remains unwritten. Beyond the Kuiper Belt, at the edge of the heliosphere, new missions prepare to cross into interstellar space. They carry not weapons or flags, but seeds, biological and digital, encoded with the potential to recreate life itself. They are called Genesis arcs, ships designed not to return, but to begin. Their goal is simple, to ensure that the light of consciousness never fades. No one knows if they will succeed. Perhaps they will drift forever, silent emissaries of a species that once dreamed too boldly. Or perhaps, millions of years from now, they will find another world, another ocean, another sky, and life in some new form will awaken beneath unfamiliar stars. The question that began our journey, are we alone, may never have a final answer. But along the way, we discovered something far greater, that the act of seeking itself is what gives life meaning. The universe may be vast and indifferent, yet we fill it with purpose simply by existing within it. Some philosophers call this the second dawn, Not the birth of humanity, but its awakening. The realization that existence is not a destination to reach, but a conversation to continue. That we are both explorers and caretakers, both creators and inheritors. And that every star we light, every world we build, is a continuation of the same story. The universe becoming aware of itself. In the quiet between worlds, there is a profound peace. The engines hum, the domes glow, the children of 1,000 suns look up at the same distant constellations and feel connected. Not by blood, or nation, or origin, but by shared wonder. Someday, future historians, perhaps born light years from Earth, will study this age and give it a name. They may call it the expansion or the age of awakening, or simply the long journey. But to us, living it, it feels like something more intimate. It feels like home finding its reflection in infinity. And as humanity moves ever outward, past the last horizon, past the known and the imaginable, a final truth endures, written across the darkness in the language of stars. We were born from a single world, but we were never meant to stay there.